Welcome to the Math 1 lecture on proportions. I'm going to go ahead and give you a few examples after I provide a definition. Right now you could probably see that my head is cut off. That's because the easel is a little bit on the low side. I can kind of kneel down on my knee so you can see my face, but it'll be easier for me if I stand up and walk around while I write things up on the board. Okay, so just bear with me. Okay, so a proportion is a comparison of two ratios. This is a ratio, 1 to 2. All right, here's another ratio, 4 to 8. And if I try to compare these two ratios and they happen to be equal to one another, we say that it's a proportion and that these two ratios are proportional to one another. So this is a proportion. One ratio equals another. And a defining characteristic of ratios that are equal to one another, okay, in a proportion, is that if I cross multiply, if I multiply those two numbers, then it should equal these two numbers. If it does, then it's a true proportion, okay? If not, then you might have made some sort of mathematical mistake, all right? So, for example, let's try to set two things that are equal, that are not equal to one another, and see what happens when we cross multiply. If I do something like 3/4 and 2/3. 3/4 is about 75%. 2/3 is about 66.7%. So these are not supposed to be equal. But let's see what happens when we mistakenly think that they are and we try to cross multiply. We get 2 times 4 and 3 times 3. And you can see that this is not true. Because that's not true, we know that this is not a true proportion. Okay? So in general, that's how it works. Now what I'd like to do is go through a series of examples and show you a few ways to solve proportions if you have an unknown. So let's start off with, got my examples right over here. Let's start off with x over 18 equals 5/6. So what this proportion says is that I've got 5/6 of something, okay, 5 out of 6, and I want to know what would be the equivalent ratio or fraction for if I had 18 objects instead of 6 objects. So for example, let's say 5 out of 6 students prefer Coca-Cola over Sprite. Over here, if I had 18 students, how many of them would prefer Coke over Sprite on average, right, at the same rate? So we want to see what that proportion would be. If this truly is a proportion, then we know that there's a property that you can cross multiply. And I can do something like this. I can say 6 times x is equal to 5 times 18. 5 times 18 happens to be 90. Okay, so 6x equals 90. And then of course, after you cross multiply, the second step is to divide. So I'm going to divide both sides by 6. And if I do that, I should get x is equal to 15 if I pop 90 divided by 6 into the calculator. Okay? So that's how you solve a proportion. All right, let's go through a second example. A second example, we've got x over 45 is equal to 15 over 25. Okay, This looks a little bit tougher because there are bigger numbers. Rather than multiplying all the big numbers together, I'm going to hold off on simplifying the numbers until the very, very end. But I'm still going to follow the same two steps. I'm going to cross multiply and then divide. Okay? So I'm going to write it out. If I cross multiply, this part is 25 times x. If I cross multiply the other half, I would get some big number equivalent to 45 times 15. Now, I'm not going to multiply those out into a calculator just yet. Let's just leave it like that. But we know that it represents some sort of number. So I've done step number one. I've cross multiplied. I'm now going to do the second step of dividing both sides by 25. And you'll notice on this side of the equation, when I divide by 25, I'll end up with x, which is my answer. But now I need to somehow simplify this. One way I can do this is by factoring. So it's perfectly fine if you have a calculator and you go 45 times 15. Okay, so 45 times 15. And then you have to divide when you go down here because it's below the fraction line. But another way that you can do this to make it just a little bit easier, and perhaps if you don't have a calculator, it'll make it easier to calculate if we reduce this, okay? And you can do this by factoring these numbers. So for example, let me just do a quick example here. This happens to be, 45 happens to be 5 times 9. So this is 5 times 9. And 15 happens to be 5 times 3. And I'm taking 5 times 9 and multiplying it by 5 times 3. So this is 5 times 9 times 5 times 3. On the bottom, I have a 25, and 25 can be broken down into 5 times 5. Notice that I can take a 5 on the top and the 5 on the bottom and cancel them, because something times 5, and that same something divided by a 5 will have the two 5s cancel out. I can also do a cancellation for the other set of 5s. And what I'm left with is 9 times 3 divided by 1. Remember, this is not 0. You canceled it out. So you might remember that when we cancel these out, those become 1s. So this is 9 times 3 divided by 1, which is just 27. Okay. Again, if you wanted to, okay, if you didn't want to go through all of this stuff, you could have gotten a calculator and plugged in directly 45 times 15 divided by 25, and you'd end up with the exact same answer. Okay. This is just the way to simplify the numbers to double check your work. All right, let's go on to another example. Okay, so in this example, I have an algebraic expression, n minus 4 over 8 is equal to 3 halves. And I want to solve for the letter n such that if whatever I get for a final answer, if I pop it into this expression, okay, so if I put n into here, subtract 4, and divide it by 8, I should get the same result as 3 divided by 2. All right? And we're going to check that at the very end. But first, let's try to get a result, and we're going to do that by cross multiplying. Now you'll notice that there are two parts here, okay? This is a binomial. It's an algebraic expression with two parts. So in this binomial, when I multiply by 2, I have to remember that the top part of the fraction stays together. So it's just one group. In mathematics, we signify that it's all the same group by putting parentheses around it. As a matter of fact, if you want, you can pretend there are parentheses around 2, the 3, the 8, everything. But we don't really like to put parentheses around single numbers, but it's required when we're going to take it. We're going to take this expression and multiply it by a single number like that. Now I'm going to take my 2 and I'm going to multiply it across this way, right? We're going to cross multiply. So this 2 is going to be multiplied by n minus 4. And the other side is 8 times 3, which is 24. In order to simplify this side, we have to use the distributive property, which I normally refer to as the rainbow. This is 2 times n, and this is 2 times a negative 4. 2 times n is 2n. 2 times negative 4 is negative 8. And then I have a 24. I'm going to add 8 to both sides. And when I do that, the positive and negative 8 cancel out. I'll have 2n is equal to 32. And then finally, if I divide both sides by 2, I'll end up with n is equal to 16. Because the 2's here cancel out, so I have 1n. And here, 32 divided by 2 is equal to 16. Now, what I want to do is check to make sure that this is a true proportion, that I solved for the correct value of n. So if I go back to my original expression, n minus 4 over 8. N minus 4 over 8, if I put 16 in it, will be 16 minus 4 over 8. 16 minus 4 is 12 over 8. And remember, that whole thing was equal to 3 over 2. So that's 3 over 2. Now you might be able to divide this in your head and realize that if I reduce this fraction, dividing the top by 4 and dividing the bottom by 4 will give me 3 halves. But the other way that we can check a proportion, if this truly is a proportion, is by cross multiplying. And you'll see that 8 times 3 is equal to 2 times 12. So we solved for the correct value of n. All right. So let's go ahead and go on to the next example. I feel like this is going to fall apart. So let's hope it doesn't. All right. In this next example, I've got x over 9 is equal to the quantity 2x minus 3 over 24. Okay. So unlike the last problem, in the last problem we also had a binomial, but in this problem, not only do we have an x on one side of the equation, we also have an x on the other side of the equation. So The steps are still the same. There's just a little bit more algebraic work to do to arrive at a final value for x. I'm going to go x times 24. So this is 24 times x. Remember that this binomial is one group, it's one unit, so you have to multiply the whole thing by 9 when you do the cross multiplication. So when I do this part of it, it's 9 times 2x minus 3. To get rid of the parentheses, I'm going to use the distributive property, and the distributive property requires that I do this little rainbow thing. This is a 9 times positive 2x, that's 18x. This is 9 times negative 3, so that's a negative 27. And on the other side, I have a 24x. I want to isolate the x, so let's remove this 18x by subtracting 18x from both sides of the equation. Don't forget that x. You're not subtracting 18, you're subtracting 18x, because canceling out a positive 18x requires that you subtract 18x from it. So if I do that, 24x minus 18x is equal to 6x. And on this side, the only thing I have left is the negative 27. And if I divide both sides by 6, so I've got to stand up for this. If I do 6x is equal to negative 27, and I divide this side by 6, and I divide this by 6, I'm not going to end up with a whole number for an answer. It doesn't mean it's wrong. We just have a value of x that will make this original equation true, but it's not a whole number. It's not an integer. Okay? This side is just x. This is a negative divided by a positive, so this is going to be a negative number. And you can put this in your calculator, but without putting it in my calculator, you can arrive at the answer of 4.5 by realizing that 27 is divisible by 3, 6 is divisible by 3, and this would reduce to a fraction of 9 over 2, and 9 halves is just another way of saying 4.5. All right. All right, so let's go on to the next example. Got a few more examples for you. Okay, in this example, I have a speed or a rate of 70 miles per hour. Okay, so this is a speed or a rate at how fast you're going. 70 miles per hour. And I want to know how far can you travel? How far can one travel after 6 hours at this speed? Okay, that's the question. So I'm in a car, I can go this fast, but what I want to do is travel that fast for an extended period of time. So after 6 hours, how far will I have gone? Now, right now, it doesn't look like a ratio. And it doesn't look like a ratio because we don't have like something over something equals something over something. Right now, you can see two numbers, right? But a ratio normally has four parts. There's a top and bottom number to the left and a top and bottom number to the right. Now, believe it or not, this is a fraction. It's a fraction because this has 2 units. And this per is just another way of saying division. This is 70 miles per hour. One way that you could read that is 70 miles per 1 hour. And I'm going to write it out like that. Now, in a proportion, in addition to keeping track of the numbers, you also have to keep track of the units or the labels. In this case, on the other side of the equation, if this is going to equal the same thing of something, the top has to be in miles, and the bottom has to be in hours. Okay? So, we have 70 miles per hour, but we don't have any information yet for this side. If I look at the problem and I look at the given information, I have 6 hours as a given quantity. That 6 hours means that the bottom number is a 6. I'm not putting it on top because that 6 doesn't represent miles. This side of the equation has miles on top, hour on the bottom, so you have to have miles on top and hours on the bottom as well on the other side of the equation. Okay, and the question is, how far can one travel? In this case, how far can be answered by a number of miles. That is my unknown. I'm going to call that x. So another way to reword this problem is, if I can travel 70 miles in 1 hour, then how many miles, x miles, can I travel in 6 hours? All right? And from here, it's just a proportion, so we can cross multiply. This will give me x times 1 times 1, so that's 1x. And then if I go this way, this is 70 times 6. So 70 times 6 is 420. And if I solve for x, well, it's already solved for x. I have 1x, so we normally just call that x. And x represents the number of miles, so please don't forget your units or your label in your final answer. So in this case, it's 420 miles. Okay? It is important that you make sure that you have that label on the quiz, on the exam. You'll be marked down for it if you don't include the label. All right, let's do another example. This is my second to the last example, so we're almost there. Let's suppose you have a different rate, okay? So we have a different ratio, something that compares two different quantities. In this case, I'm going to say that at a certain job, somebody is making $8 per hour. You often see people's wages written in this form. And for this particular person, they're working for $8 an hour, and they're trying to save $112. And the question is, how many hours must this person work? If this person continues to make $8 every hour, you don't get a raise right in the middle of the shift, but you just make $8 an hour. For how many hours do you have to keep earning $8 an hour until you save up enough money equivalent to 112? Okay? So this is a proportion. This is a proportion, okay, a proportion problem, because this has a top number and a bottom number. When it says per hour, you can think of it as per 1 hour. $8, dollars is the unit. We happen to write it on the left of the number instead of after the number. But this is $8 for 1 hour. If I have dollars on top and hour on the bottom, on the left side of the equation or the proportion, I have to have dollars and hour in the same places on the right side of the equation. Now last time we were given the number of hours, the bottom number, but this time we're given the top number, which is 1/12. So my x is actually on the bottom, because that is my question. How many hours? Hours is unknown. Okay? So from here, I'm going to go ahead and do a little bit of multiplication. If I go 1 times 112, 1 times 112 is 112. And going this way, I get 8x. So 1 times 112, that should be obvious. It's just 112. I'll scratch that out. Now I need to divide both sides by 8. And what I will end up with is my answer. It looks like that's going to equal 14. So in my calculator, if I go 112 divided by 8, I should get 14 as my answer. But remember, you need to include the units. All right? In your final answer, ask yourself, what is x? X represents the number of hours. So your final answer is 14 hours. Okay. And then finally, we get to our last example. This is a geometric problem, a geometric application. All right. So in this problem, we're going to start off with a right triangle, like that. We're going to say that I don't like this size of this triangle. I'm going to redraw it and exaggerate it a little bit better. There we go. So I've got a triangle like this, okay? And it just so happens that it is a right triangle, and the legs, or the two sides of my triangle, are 5 and 12. And I want to make this triangle bigger, but I don't want to make just one side bigger and because if I make just one side bigger, it's not going to look the same. So I want to make this triangle bigger and make it look the same. I want to make it look proportional, which means that if I increase the bottom part of the triangle by a certain factor, I have to increase all the sides of the triangle by that same factor. All right. So it also means that if I want to shrink the triangle, I should cut all of the sides by the same fraction. So if I want to cut it in half, then I have to divide this by 2. I have to divide that by 2. If I want to make it twice as big, I'm going to have to multiply by 2 and multiply by 2. And the triangle that I'm trying to find is this one, okay, such that this has 60 units of length. So let's just call this inches, just so we've got some sort of unit. So from 12 to 60, if I blow this up so that it's that much bigger, the question is, if this triangle remains proportional, okay, so I have a similar triangle, then how big will this part of the triangle be? Okay, how long will that side be? That's my unknown, so I'm going to call that x. And I'm going to think in my head, how am I going to set up this proportion? I'm going to set it up in such a way, all right, and it doesn't matter which way you go, but as long as you're consistent, but I'm going to set it up in such a way that the side that is vertical is going to be the top part of my ratio. The side that is horizontal or flat is going to be on the bottom. So if I set up this ratio to solve for the length of the large flat side of the big triangle, it's going to be 12 over 5. So this is 12 inches over 5 inches is equal to inches on top, inches on bottom. We're comparing the 12 to the 60, so the 60 is on top. And the 5 corresponds with the x on the bottom. And now I can do a little bit of multiplication. 12 times x, there's my cross multiplication. And then I've got a 5 times 60. That's my 300. And if I divide both sides by 12, and I pop this into a calculator, my final answer should be 25. And this is going to be in inches. Okay, so that was quite a few examples of how to use proportions. So again, feel free to rewind the video and review any of the material that might seem a little bit unclear. If you have questions, write your questions on the side. When we bring the class back together as a whole, as a group, be sure to ask these questions, and we'll be sure to address it so that everybody understands. Everybody understands the issue. Okay? All right. Thank you very much.